This is worksheet 8.3. Here we go, working with the natural log. So we're going to calculate those with a calculator to the nearest 3 decimal places. So type that in. Might look like E. You might have to use the power key or the XY key and then 5. So you get 148.413. Here make sure you use parentheses around your exponent. If you're using like a TI-30 calculator, a calculator that we provide here at school, essentially what that's doing is making sure that the calculator understands that 3 is also part of the exponent. And if you're using like your laptop, typically you'll see that that's actually an exponent that's being written up there, so you don't need the parentheses around it. So make sure you get those answers. Tell whether the function is an example of growth or decay. So here we'll have growth because our exponent is positive. Here we're going to have decay and decay. Evaluate the expression. So when we have a power to a power, we multiply the powers together. So that's e to the negative 8 or 1 over e to the 8th, because that negative exponent makes it a traitor. Move it to the opposite side of the fraction bar. Here, we divide the numbers. 3 divided by 1 is 3. And then we subtract the powers. And e to the 5 minus 1 is e to the 4. We'll sprinkle the power of negative 1 to everything in the parentheses. So we get this. And then we don't want an answer with negative exponents. We move the traitors. This top value has a negative exponent, so it moves to the bottom. And its power becomes positive. And this bottom one is a traitor because it is a negative exponent. So we move it to the top and make its power positive. And then really we just write it as 2 over e, because we don't need to write the power of positive 1. Sprinkle the 2 to the number, or to each of the factors. So we have the number 4 and we have the value e to the third. So 4 squared gives us 16. And then e to the third to the second power, we multiply the powers together, so you get e to the 6th power. Here we can rearrange this as negative 3 times negative 4 times e squared. So this says negative 3 times 4, that's negative 12. This is e to the power of 1. When we're multiplying the same bases, we add the powers, so we get e to the third. I could rearrange this one as well, I suppose. So there's nothing to multiply the 2 with, so I just bring that down. Remember what we did with the powers? Over here, we add them together when we're multiplying the same bases, and we're still multiplying the same bases together, so we add the powers together. So now I'm adding x plus 3. So how do we simplify that? That becomes 2x to the third, or sorry, 2x plus 3. So that is my power that I'm talking about. So the base is e, and now the new simplified power is 2x plus 3. Let's try a little graphing. So it says, graph the function, state the domain, range, and horizontal asymptote, although that part got cut off. So remember, you're just going to graph the parent function, or the mother function, and that's just the coefficient, the base, and the power of x. Just the power of x. If there's other powers behind it, we leave that for the time being. Negative 2, negative 1, 0, 1 and 2 are good numbers to try to reference your graph around. Round these values to the nearest 100th or 10th. It's going to be hard to write these in there for me with this pen. So we get negative 2.7 and 7.73. When x is 0, y is 2. And again, that's just in this function right here. 2 times e to the negative 2 equals this. We're going to worry about that minus 3 in a little bit. When x is 1, y is 5.4. When x is 2, y is 14.8. So let's graph those. So negative 2, 0.27 is right about there. Negative 1, negative 1. 0.73 is still going to be below 1. When x is 0, y is 2. 1, 5.4 would be between 5 and 6, technically closer to 5, but it's pretty hard to tell on this thing. And then 14.8 when x is 2. You're right around there. So this is the parent function, which I've highlighted. But now this minus 3 is going to give us a shift down 3. So I take every single point and I move it down 3. So now we're right about there, right about there. Right about there. And so instead of, if you look at the red dots, these would, and if you're ever uncertain, you can test these negative numbers. You can punch negative 12 into your calculator. It's going to give you a number just above 0. So these red dots would, well, we're going to go with it, would continue to get close to 0, but not quite touch it. So the parent function has a horizontal asymptote at 0, but that's not the equation that we actually want to talk about or graph. And so because we're moving this graph down 3, holy cow, make sure your dots are obvious, because if you make that curve nearly as bad as mine, we want to see the dots so we know where you were trying to hit. Boy, I almost need to make those dots again. There we are. So I can see those now, and now because I shifted it down 3, instead of the asymptote being at 0, it's going to be, well, now these are all the y values that are greater than negative 3. The domain is all real numbers. You can punch any tiny number in, any negative number, or any big positive number in. The range is going to be y is greater than negative 3. And so I got ahead of myself on that range. I was trying to answer the range when we'll want to write that our asymptote is at y equals negative 3. That means the y values will be, in this case, greater than negative 3. Let's try this one. So here is your parent function, which you're going to plug into the calculator. And then the plus 2 means that we're going to shift to the left 2. And then the plus 1 afterwards means that we'll go up 1. So we'll take all these points and shift them left 2, up 1. So we'll plug in these values to see what they get us into this mother function. So this first one is going to be e to the negative 2. So yes, that makes a positive. Negative 2 is really the same as positive 2. So you get 7.4. When you plug in e to the negative 1, you get 2.7. Then 1, then 0.37, then 0.14. So this is the parent function. We'll still have to do this shift in a little bit. Let's graph that. There we are. But now we need to do the shift. So we're going left 2. Oh, I shouldn't have used that color. I wonder if I can switch that automatically. Let's give her a shot. Bum, bum, bum. Color. Let's make it yellow. My green dots still don't show up very nicely. There they are. So those green dots that I really want to see, I want to shift those dots or points left 2 and up 1. This will give me the new function left 2, up 1. All right, let's graph it. So the yellow line was hovering just above y equals 0, but now because we shifted it up 1, holy cow, my straight line skill is not happening right now. Because we shifted it up 1, it'll be hovering just above the value or the line y equals 1. Let's take this yellow line and put it back down where it belongs. Yeah, that's not a very straight red line, but I think we can answer the question. So our domain, all the x values, we can plug anything we want in for x, so that's all real numbers. Our range is going to be y values that are greater than 1. And our asymptote, the line that it seems to approach as we go to infinity but not quite touch, is going to be y equals positive 1. There we are. Let's try number 24, wherever this number is. So you deposit $725 into an account that pays 4.5 annual interest compounded continuously. What is the balance after 3 years? So the amount is going to equal, here's where we use the APERT formula. So the principal, or the investment amount, the starting amount, times E raised to the rate times time. And so our interest rate needs to be converted to a decimal. So divide by 100, you get 0.45. So E to the 0.45, just kidding, 0.045. So it'll be E to the 0.045 times 3. When you do that, you should get $829.79. Boom.